Hi, thank you for coming. So I'm going to talk about the ORC improvement in Apache Spark 2.3. So my name is Dong Junhyun. I work for Hortonworks data science team as a principal software engineer. For Apache project, I am the Apache Leap PMC member and committer, and recently I'm focusing on Apache Spark project. So today's talks, I'm going to start with the Apache Spark 2.3 new release, new features, and narrow down the ORC improvement only. And for the technical detail, I'll cover the previous ORC issued in Apache Spark. And now I'll introduce the current approach and show you how to use as a demo. And I conclude that the performance and current limitation and future roadmap. So maybe you are familiar with this kind of slide. So what's new in Apache Spark 2.3? The Spark 2.3 is the fourth feature release in Apache Spark 2.x line. So there is a lot of feature. This is a very short list. And actually, in this morning, there is another session about the PySpark and the other stuff. So I'll skip the other things. So we will focusing on the ORC part only. So in Apache Spark 2.3, the new Vectorized ORC Reader is added. So the read performance is greatly improved. And also structural streaming with ORC is now officially supported. There is some issue previously reader side and writer side. We will discuss about that. And also we improved the schema evolution capability in ORC data source. And finally, the PySpark performance is greatly improved with Apache Arrow and ORC. So the Arrow is the in-memory columnar format, so it works with ORC very well. So Spark works very well with a variety of data source, especially this is 5 built-in data source. So this is commonly used, very popular. The text is the very simplest one with one single column schema, and CSV is popular for data science workload. JSON is the most flexible one for schema change. I mean, in this Spark capability, every data source has different capability, and the feature is not the same because some part is Parquet is advanced, and some part is ORC is advanced, and JSON is also the same. And Parquet was the only one with Vectorized Reader before, but now ORC supports that. And ORC is popular for shared Hive table. So actually, we want to improve Apache Spark. The motivation is to give more faster and more flexible, and to provide a better Hive table access. So our approach is to choose ORC and to improve some more feature like Parquet and JSON. That is our approach. So there is many ORC issues, so we were surprised that we need to solve everything. But until now, before going further, the issues one by one, we need to understand the history of the ORC and Spark. Actually, Spark 1.4 add Apache ORC dependency. So the ORC is columnar format, so it is also very satisfiable at that time. But the problem is here, still now, Spark 2.3 has the legacy code. I mean the old ORC implementation based on Hive 1.21. This is a very old one. But the problem is Spark cannot upgrade the Hive submodule dependency. So previously, Spark stick to the old Hive 1 and old Hive ORC. So for 3 years, the ORC is developed by itself. So it became an Apache top level project and released several versions. And finally, last year, it successfully released 1.4 without Hive dependency. So I mean, the Apache ORC can be used as a standalone library without Hive. So this is the line. The Hive also, the ORC is split out from the Hive, and Hive now depend on Apache ORC officially. So the latest one is Hive 2.3.3. It is also depend on the stable one, version 1.3.3. And Spark 2.3 is the first release to use the Apache ORC 1.41. So it was the very latest one. But 2 months ago, there is another one for stability issue. So now the next future release of the Hive and Spark, Hive 3.0 and Spark 2.4 will use the same Apache ORC library. I mean, the core is shared commonly, so we can expect that many compatibility issues is resolved. This is the story of Spark and ORC and Hive, and actually this is a happy ending story, so everybody will live happily forever from now. I believe so. And one another thing is during this change, the Spark now allow the user to give the user provide ORC version, so the user don't need to wait the Spark another release, just change their own ORC version and use the latest one anytime. So there is many issues, but the ORC issues fall into this 6 category: the ORC Writer version, and performance, and structural streaming issue, and column name issue, then schema evolution, especially inside the Hive table, and the other thing is the robustness. Actually, the ORC have 7 versions. So in the big data world, the data is written once and read many times. So the read performance is very important. So reader is considered very important. But writer is also very crucial because we cannot change after write once. So Spark used the second one, the Hive A732, that is version number. So the Spark's technology is behind 4 years. So there is many fixes column name, Hive decimal issue, and default character issue, and predicate pushdown issue. This one is resolved. So Spark 2.3 used the latest one, the ORC 135. So it resolved everything from the previous issue. So this is a writer version. So this is important because some operation like predicate pushdown, and this specifically the predicate pushdown for timestamp, it is simply ignored if the ORC file is written by old writer version. So the performance will suffer very much. So we need to write new data with a new version. That is very important. So for the performance issue, the ORC is columnar vectorized format. It supports very fast access, but if Spark tries to read the record by record, it cannot be fast. So that was the issue. So we implement the Vectorized ORC Reader in Spark 2.3. And also there is another issue. So this issue name is the fast reading partition column. So actually partition column is not stored inside ORC file. It is inside the metadata or some directory name, so Spark inferencing from that. But some strange thing is it is slow for ORC data source, especially. For the Parquet, there is no problem. So we implement the ORC part about the partition column. Also, the other thing is the date type. The Spark previously does not support predicate pushdown for date type, so we added this in Spark 2.3 for ORC first. And actually, this is happened for the same with Parquet. Parquet still does not support predicate pushdown for date type. Spark 2.4 will support that later. There is ongoing work about that. The other thing is structural streaming. Structural streaming is very popular in Spark. Many people want to try, but suffer from the ORC. It failed to write. And the read path is just the API issue. The API is missing because previously the writer does not work correctly. So the issue previously when you meet is the file not found exception. Let's assume that you receive the data from the Kafka data source. Then the Kafka data is split into multiple partitions, and Spark consumes each partition. And sometimes one of the partitions may have no data. So in that case, the empty partition is came. Then the behavior of structural streaming is consisted of 2 parts. One is write the data file into some file, and second phase is the commit. So for all the other built-in data source, it works correctly. But the old ORC file does not create ORC file if the data frame is empty. So for the Kafka empty partition, there is no ORC file. So at the commit phase, Spark just failed without file not found exception. So there is some kind of the contract issue between the layer of Spark. For the read part, actually, the ORC Spark.readStream.orc is synthetic sugar. We can use the format parameter instead. So it is the same thing, but it is documented API. So we add seamless with other built-in data source. So it is supported. So during this week, we add many test case about that, improve test coverage, and also added some document to support officially this. The other thing is column name. For the other built-in column, I repeatedly said this one because not all the data source is the same. The ORC specifically does not support Unicode columns and column name with that. That was the issue for many data scientists. So it is resolved in Spark 2.3. And also for the invalid column name, there is still invalid column name. The previously Spark raised the runtime exception when writing data file, but now it detects this kind of invalid column name at the analysis stage. So it raised analysis exception before executing the Spark job. So Hive table can change many times. You can assume that there is an alter table add column, and also there is an alter table change type that is frequently used, and there is many customer demand, but Spark does not support that before properly. At the Spark 2.2, there is Spark add the support of alter table add column, but for the ORC, unfortunately, it does not support it because the old Hive 1.2 has some kind of issue. So it is also resolved. So now the alter table add column is supported for ORC without any problem. And the other thing is the column position. The ORC file has the file schema, and there is a Hive meta source schema. There is two schema. So if two schema is different sometimes because user change the Hive meta store, the column order. So every column exists in the same name, but the ordering is different. In that case, previously Spark returned the wrong result. This is one of the schema evolution issues. The other thing is the ORC file is contain a lot of metadata. So some metadata grows bigger than 64 megabytes before, then it failed to write. It is fixed by Hive and ORC long time ago, but Spark cannot bring the patch into current one, but now it is resolved. So ORC metadata can grow into 1 gigabyte, so there is no issue about now. So the other thing is the third-party data ingestion tool like Plum generates sometimes 0-byte ORC file. It is named the ORC, but the file size is 0. In that case, the Spark raised null point exception before. It is the behavior of Hive 1.2, but now is fixed. The ORC is considered that kind of zero size file is as just empty normal files. The other thing is the Spark configuration. It is supported for robust operation, ignore corrupt file or ignore missing file. This kind of operation exists, and it is supported for all the other built-in source, but only ORC was missed before. So until now, there is many issues, and I only summarize typical issues. Those issues are resolved in the current approach. The current approach, we add another new file format with for ORC using Apache ORC. So in that case, you can see the native ORC file format is based on Apache ORC, and Hive ORC file format is just the existing one. We name it just alias. So this is the class hierarchy of the file format in the Spark. The file format, you can see that there is text-based file format. The CSV and JSON is inside that, and the Parquet and ORC file format, and another ORC file format and Hive file format. The upper one is the new one, and the lower one is another the existing one. So we add one data source, but actually there is a reader and writer. So we have two reader and two writer from both file source. So there is 4 cases. The user will hit this case, the new writer and new reader. Actually, new application prefer this one. So generate new data, and the performance is the best one. So case 2, we have a lot of old data. We cannot regenerate or rewrite that kind of issue. Sometimes we can backfill one by one, but it's not feasible. It is a waste of resource. So in that case, we just try to vectorize the reader on the old file. Also, this shows improved performance because vectorized reader work without any problem. The case 3 is we already have our existing data pipeline. So data pipeline, we cannot change that. So the pipeline consists of the old Hive reader. In that case, the new ORC file is recognized without any problem, so we can use that. Even in this case, there is slightly performance improvement. And the case 4 is old Hive reader and Hive writer. This is Apache Spark 2.3 default options. So if you didn't change anything, it worked like before. So you don't worry about any regression. This is just one example. I bring this one from the Apache Spark benchmark. It is just read one column from a wide table. The x-axis is number of columns. So there is 100 column table and 200 column table and 300 column table. As you can see, the name is the same. 1, 2, 3, 4 is the one is native reader and native writer. In this case, the performance is 4 times faster. And case 2 and case 3 is also show better performance than the previous one. The previous one is number 4. And also it's more scalable with a column numbers. So how can use the new native ORC file format directly? Spark support this like this. The ORC Apache, you can give the class name directly, and in the format option, or if you create table with using syntax also accepts that kind of class path. So in this case, the specifically assign the native file ORC file format, so you can use without any problem. But one drawback of this approach is you need to change your code. So we don't want to change our code. So the other option is configuration. This is a new Spark 2.3 configuration. So Spark, SQL, ORC, impl is native. The default is Hive, as I told you before. By default, it doesn't change anything. But if you change this configuration as a native, then every operation is go to native ORC file format. So Spark read ORC, write ORC API, and read format ORC, write format ORC data API, and also using ORC option. All this kind of operation is considered as alias, so you can switch into native one. And also structural stream is the same. The Spark read stream ORC and format ORC, and also writing operation. Actually, for the writing operation, there is no shortcut of API. So it's simple, just configuration, and actually you don't need to change anything from the code. So for the advanced user, there is more configuration. So if you want to control more details or behavior and want to choose, actually we provide 3 columnar batch reader. So if you want to choose just one of them, then you need to configure this. The ORC input is the starter menu. So there is Hive and native again. And then we can go to native path. So the Spark support vectorization only when all column is atomic and the column number is less or equal than the code gen max field. This is common for Parquet and ORC. So in this case, you may increase the configuration max field with more higher number, but everything will be the same. So in that case, if some column is complex type, non-atomic type, it goes to native ORC record reader. And also the table is very wide. In that case, it goes to native ORC Reader. And also there is an explicit configuration. You can turn off Vectorized Reader completely. In that case, also go to native reader path. After we pass all the 4 conditions, we go to ORC columnar batch reader, and finally. So there is 2 more configuration and 3 code paths. The one is here we are trying to access the ORC column structure into Spark column structure. So there is one approach, is a wrapping approach. Wrapping approach does not cause a memory copy, but it causes a lot of operations. And also, we can try to copying the ORC column vector into Spark column vector. But Spark column vector has 2 options. One is off-heap column vector, and the other is on-heap column vector. So that is controlled by that kind of operation. So the green one is the default one. Actually, the performance is different for situation, but the wrapping one is very fast for string and byte array. So there is some issue to retrieve the data from the Hive ORC. So for the byte and string case, we just call copy or 1 by 1. So in that case, the wrapping approach is more the best one. So until now, I described the ORC file format of data source, but there is a Hive table. The Hive table is originally supported by this option. It is introduced in Spark 2.0, the convert methods to ORC. The Parquet has the same one, convert methods to Parquet. So previously, our Hive table is considered Hive table, but this option makes that Hive table into data source table. And data source table can be read by Vectorized reader. So this option is crucial. And also, of course, you need to turn on the Spark SQL ORC impl true, impl native together. Here, there is 2 syntax. You can notice that one is Spark's table creation syntax, and the other thing is Hive's table creation syntax. The first one is using Hive option file format ORC. In this case, it creates Hive table with ORC file format, and there is some ORC option. It works without any problem. But the below one is the Hive syntax. It means Hive table also. But in that case, the table property is not supported. So it means the ORC reader will work by default configuration. You cannot change some input split or something like the ORC specific options. You can give by the Spark configuration or some other way, but table property is ignored. That is Spark 23355. We are trying to resolve this one. Yeah. So this is schema evolution at reading file-based data source. So until now, we didn't support the alter table change type, but this is you can use the Spark data source API like this. So frequently, new files come here with a new column or wide column. So in that case, you can think that old data is consists of one column of column 1 integer type, but the new data have another column 2, the type of long, and also the first column is the type is changed into the long, so it is widening. So in that case, we can give the user-defined schema. For Hive table, it is Hive metadata schema. So Spark read Hive metadata schema and fill in these options. So in that case, if you give some wider column, like full into byte, byte to short, short to int, and long, in this case, it works in a natural way without any problem. And also float can be cast into double. This is a kind of alter table change type. Hive works in the same way. If you want to try narrow down, it raises exception. And if you try to wide column, then it accepts the change. So this is the summary of all tables schema evolution capability. I already mentioned that every table does not have same capability. In this case, text is always have one single string column, so there is no schema evolution. And CSV does not support hide column. I mean hide is, actually we cannot delete the existing file. It just hides schema. So the hide column means hide some column in the middle, and the Hive trailing column is just truncated at the end of the columns. So the CSV does not support that kind of operation. And also, we can, for CSV, we cannot switch the column positions. So JSON and ORC and Parquet support more general schema evolution. But for the Parquet case, the schema upcasting was not allowed until now. So there is some issue. But still, there is a Mark 3 on change type. Still, JSON is the most flexible one to change type for the specific ORC case. Only allow this kind of combinations. So you cannot assume that all kind of compatible things. So among the vectorized one, the Parquet and ORC, the ORC is provide the most flexible schema evolution. So yeah, let me give you the example of how we work as a demo. And the second demo is also the, the second demo is, it consists of two demos. One is configuration demo, and the second demo is PySpark. It means arrow operation in the ORC. The first demo is using the Zeppelin. Something wrong. It's play in my notebook, but yeah, sorry, but you can see it. So I skipped the first part. It launched the Yarn client. So there is a Spark SQL ORC implementation native and generate to ORC native file and turn off that back into Hive file and create ORC Hive. This is sample generation for 10 rows. And you can check the file version. So first one is ORC native, and the second is ORC Hive. And you can notice that the file version is changed. The ORC native uses the latest one, and the old legacy one is still stick to old writer. So now we want to generate 100 million rows. In this case, we want to avoid the sequential string generation. So we generate 100 million rows and sampling the half. So roughly 100 million. In that case, the name is ORC underbar 100 million underbar native, and Hive is respectful. For the writing performance, it does not difference. There is a still ongoing work about writing part. So for both table, we do the select count. So you can see that the native one is 300 milliseconds, but the native one is 20 times slower in that case. But in this cluster is a VM node, so the performance number is different in the situation. Yeah. And also, this one is the creating table. This is creating Spark table, not Hive table. So the ORC1 and ORC2 is the same sequence, and I select count star from select count star from table is executed. In this case, the number is too small. So anyway, you can see the ratio. The native one is already completed in a short time, the 500 milliseconds, and the second one is still running. Yeah, it will finish very soon, maybe. Yeah, it's 10 times slower. I mean, the new one is 10 times faster. The count is the same. Yeah. The other thing is the Hive table. So Hive table means here using the stored as ORC syntax. In this case, we mean Hive table. So we create the Hive table also like in this way, and turn on native option and select count, and turn off native option and select count, the same thing. So native one is already finished. It's just less than 300 millisecond, and Hive one is very slow. That is existing. Yeah, this one uses Jupyter. Everything is working on the Apache Spark 2.3. So in this case, we generate one data frame and write into ORC and write into Parquet. Actually, both one is support vectorized. So in Spark 2.3, the arrow support means this one, the execution arrow enable true and false. You know that two pandas is converted from the Spark in-memory structure into pandas in-memory structure. The new one is already finished, 300 millisecond, but the old one is, this is in-memory conversion. It is, 20 times slower. So now we cannot have always in-memory data. Use already stored the data. So let's see from the reading data file and read ORC, read through ORC and two pandas, and read through Parquet and two pandas. The performance is very faster. So that is not a rigorous experiment environment. So actually, there is a micro benchmark in official Apache site. So I use that one. So this is done on Apache Spark 2.3 official one, and that one is use Apache ORC 4.1, and it is run by my laptop. Familiar? This is the. I see something. Yeah, something. This is the same one. I just show the case one, native reader and native writer, and the Hive reader and Hive writer case. This is focusing on single column access to show data type effect. It generates 15 million rows in a single column table and try to read that very fast. For the tiny int, it's 10 times faster, and small int 11 times faster. The ratio is varies on the data type. In double type case, it is 5 times faster. Maybe the data type is big, then the growth is slowed down a little bit. This is another experiment about the partitioned table. We generate 50 million rows partition columns and split into two partitions and read this one is data column only read, and this is partition column only read, and this is select both one. In that case, you can notice that the partition column read case, it is 21 times faster than before. Predicate pushdown, yeah. For the predicate pushdown, I compare with the Parquet because the older Hive implementation does not have any vectorization, as the performance is very different. So in this case, you can see that the select all column and select 90%, 50%, 10% consistently ORC show better performance. Actually, the selectivity go down further, 1% on less than a few rows. In that case, the ORC is extremely faster than Parquet because the ORC have index inside the ORC file, but Parquet does not have that. Also, we can turn on the bloom filter in ORC. That is not officially supported in Spark until now, but in that case, it is also boost up the speed. So this is the current implementation and the performance, official performance. And there is a limitation. So I already mentioned that Spark vectorization limitation. This is not about the ORC part, but it supports only atomic types. So if you have many complex nested one, the vectorize does not work well. Also, the schema evolution is, until now we achieve this kind of operation, we need to evolve much things. And finally, we need to support the alter table change type syntax later. And also, this one is the Hive table property is ignored. This is across both ORC and Parquet. We are working on it. Currently, in this month, Spark 2.3.1 may be released. We are preparing the release, but the next official feature release is Spark 2.4. In this case, we already prepared the native ORC implementation by default. It is turned on, and also turn on the Predicate Pushdown by default, and convert meta so ORC we want to enable by default. So you access Hive table without any configuration. And also we are trying to test ORC as a default data source format. Currently the Parquet is the default one, so we change this ORC and see what kind of operation or some machine learning API, there is no regression or not. That is our concern. And the final one, the Bloom filter support. Actually, if you give the ORC option, the Bloom filter is already generated, but we didn't cover all the case, so this is not officially supported. This is ongoing one. I mean, this is not included in Spark 2.4, but if we can achieve this goal, we will put this into Spark 2.4. So vector UDT and matrix UDT is machine learning, Spark machine learning data type. The ORC support that type. It can store and read without any problem, but it recognized as a general type. So the vector UDF and matrix UDF is a composite type. It consists of several data types, primitive data types. So if you store into data type into ORC and retrieve that, then type is not anymore the vector UDT. It is general or composite of primitive types. And also we want to support a character and varchar type support. And in the community, we are discussing about the data source version 2. So in that case, there is a hope to support vectorized writer for all the data source, but until now, there is no implementations. And the final one is the final piece of the schema evolution. We want to support alter table change columns. Here is the summary. Apache Spark 2.3 start to depend on and take advantage on Apache ORC, so we can implement native vectorized ORC Reader, and it boosts the Spark performance very much. Even PySpark case, you can notice that the PySpark, in the PySpark, the arrow and ORC work very well. And also, it provides better schema evolution ability. And in Spark 2.3, structural streaming starts to work ORC, both reader and writer side. And Spark is just a start of using it. So Spark is going to become faster and faster with ORC. That is our approach. So you can see the demo video through the YouTube, and there is the ORC improvement technical article on the community side. Actually, I didn't include the TPCDS 10 terabyte or large scale size. It is executed last year, and there is a presentation about that. At that time, we used that vectorized, used the new ORC file format on Spark 2.2 and on HTTP cluster. But nowadays, we have some number on Hadoop 3 and Spark 2.3, but it is not included in this slide. So, any questions? Oh, yeah, please.
So I have a question about ACID features. ACID in Hive, when you enable a transaction is equal true for a table. Also, what's the plan about bucketing?
Oh, yeah. Actually, that is important application for ORC, and ORC support that very well. But until now, in Spark community, there is no corresponding activity about to support the ACID feature. But But this is based on the urgent request. The ACD one is also on the list. We are pushing that activity in the Spark community. Maybe later. Yeah. Oh, yeah. Until now, the Spark bucketing is different from the Hive bucketing. It is difficult to coalesce two kind of approach into a single one because actually the hashing function is not the same. Also, the Hive is a moving target. The Hive is Hive 3.0. So doing another approach. So we want to watch it, and we want to some final solution to accept in the Hive Spark side. Yeah. So until now, there is not much progress on that. Yeah. Yep, please.
We have some applications where column types changes from, I don't know, string to array and this kind of
Oh, string to array?
Yeah. I think in ORC there is this concept of a union type.
Yeah, ORC supported, but Spark does not have that notion. So is
Is there a chance that Spark edits the concept of a union type?
yeah, it's possible, but I'm just wondering that the Hive support that. I mean the string to array, because I didn't try that before. So if a Hive support first, then you know that the approach is Spark support and follow on the Hive's case.
Yeah, I think you can read it with Hive. You can express it in Hive. You can read it in Hive, but I'm not sure whether you can read it with Spark.
Yeah, I'm not sure until now, but let me check later about that case. Yeah. Yeah, thank you so much. Yeah.